Live. Hello, everyone, and welcome to the first CreateOS Lounge that I'm doing this week. Today, I'm joined by members of the Vectorize team, Chris and Nicola. For some context as to how I came across these stellar builders is via the routine that I have in place now, which is on a daily basis to sort of scrape and look at GitHub trending. So Hindsight, which is their latest work of art, right? And we'll delve deeper into what it is. And I just thought, okay, these guys are sort of legit. Metrics are crazy. We can understand a little more also about that and how things are going. And it all happened very much organically. So here we are. Guys, if you can introduce yourself, and then probably we'll take it from there.
Sure, I'll start. I'm Chris Bartholomew. I'm a CTO of Vectorize and one of the co-founders.
Yeah, I'm Nicola, and lead software engineer at Vectorize, and in the engineering team behind Hindsight.
Okay, amazing. So maybe, because I know that you guys have sort of worked together in the past, right? So maybe we can take at a high level to first define what Vectorize is, right? And then also understand how you guys came to work together. And yeah, that's just to provide some additional context as well.
Sure, I can give a little bit of history of Vectorize. I have a long history, and I think everyone at Vectorize has a history in data processing, data movement. We're data people. I had started a company in 2019 called Kesk, which was built around Apache Pulsar, which is an alternative to Apache Kafka. DataStax is the Apache Cassandra company. They bought my company in 2020, and so I was working at DataStax on Apache Pulsar products. So we're all open source. We're looking at data processing, data projects, and this is how I personally met Nicolo. He was working in the Pulsar project, and we were looking to improve our team, and so we hired him at DataStax. So that's kind of how we met each other. When we were at DataStax, me and my co-founder, who's also named Chris, to keep things confusing, we were there when sort of the ChatGPT moment happened, and Cassandra being a database at the time, but did not have vector search, similarity search capability. Nicola, remember, this was a big push from the CEOs to go into that space. So we were doing a lot of projects with similarity search and vector search. And what we were seeing is that the problems that a lot of customers were having were around getting the data into the vector database, not necessarily using the vector database. And since we were in the data processing, it was our background, we thought we could solve this problem. So that was when we started Vectorize to tackle the issue of how do you deal with data and AI, because it's not the same as traditional data, same as traditional ETL. So that was sort of the genesis of Vectorize.
Amazing.
Go ahead.
I joined Vectorize after a couple of months, because we had clear, at least in my mind, was clear how RAG should have been done at that time, and the goal and intent of Vectorize was pretty clear, pretty in line with the market that was evolving very, very fast, and is still evolving very, very fast. And so I was very happy to join, basically as a founding engineer, if you look at the timing.
Right.
Okay. So maybe, Chris, this is for you. This is a question for you, right? And also for you, Nicola, is sort of at what point, because you've sort of contextually presented it, right? But I wanted to understand at what point did you specifically realize was missing in the current AI stack when you started Vectorize, right? And what was sort of your thought process? Was it to first approach it just purely from a technological and architectural standpoint to understand, hey, like I realized this problem, this is missing, I can put in place a solution? Or did you also do some sort of, what can I say, macro evaluation as to, was there something already present, like a competitive analysis? If so, what were the current players looking like? And, I could do better based on such and such skill set.
Yeah, well, like when we first looked at it, it was from a technical perspective. I think one of the things, the early thesis was that getting the data into the AI systems in real time was going to be a differentiator, and sort of having worked on real-time processing engines like Apache Pulsar, which is what we were experts in at the time, we thought that would be a good fit for this market. And because it's not like a lot of people were still doing it in the batch way. Even people who had figured it out had pipelines, but they'd be doing it in a batch way. So you would be taking all the data from all your sources and running it through, and then updating your vectors in your vector database. But then the data changes, right? It's actually in a real organizations, the data is changing all the time. You're getting new documents, the documents are changing, you're deleting documents. So it's important to keep them in sync. So that's kind of where we thought we could leverage the real-time capabilities of a platform like Pulsar. And in fact, our original product is built on top of Pulsar, as you can probably imagine. Keep the data in sync. So that's kind of, I think it was a technological thing. RAG at the time was a buzzword, and we thought we could do RAG better. I think, yeah. What were your thoughts, Nicolo?
Yeah, and also it was very basic, I would say. Now with RAG, if you look into the RAG topic, there are a lot of techniques, a lot of different solutions for basically the same problem. But at that time, like, it was all the applications built with AI and RAG was chatbots. Like, literally, I ingest my data, I get the model to answer a question. So it does a query on a database, vector database usually, and you get some data. You don't know if those data are valid or not, and you just put in the context window. And also at that time, the models were much more limited on the context window. So the real game there was, I need to retrieve the smallest amount of data that is enough to answer the question correctly. And in order to do that, you need a specialized vector databases, which was also the all the business that vector databases were doing. Is there's nothing on the indexing part that is actually standard today, because this is a new problem. It's not really new, but is getting like the market that is getting is way larger than before. And so there was also this vector database race, I would say, along with the RAG.
Yeah, you mentioned, I mean, RAG is not new, right? It's something, as you mentioned, that was done probably, I wouldn't say half-assedly, but probably not optimized, right? And sort of, yeah, I would say optimized is the best term. So correct me if I'm wrong, right? Like these are terms that I do hear quite often, but it's not part of my day-to-day. But the main sort of hindering factor, right, that I hear when it comes to RAG is scale, right? So how were you guys able to, without actually sort of first understanding how Vectorize is doing it today, right? I think it would be also useful to understand the thought process from your end of, okay, we have this sort of expertise and current skill set given our background, but it's a different beast altogether once you sort of focus on something, right, and want to do it properly. And so, for example, like we give you this example, right, for CreateOS, we factored in scale from the first version, right? So that we knew that we wanted to put together like a pristine deployment experience end-to-end for builders, so that they will be able to integrate both backend and front end and, you know, all the intricacies of app development from day one, right? Was this something that you guys did as well with Vectorize, or is it something that came after?
No, well, definitely from an architectural standpoint, like this is when I was setting up, the first solution, our RAG solution, being able to have it scalable was a key design consideration, which is why we built it on top of Pulsar, which was a proven scalable messaging platform. And so
right.
that we had the architecture, I believe, and we had, and some of our early users were doing tens of millions of documents using our system, like right from day one. One of our very first users was like, "Can we do 1 million documents?" And we said, "Yeah, go for it." And they did. It took a little while at start because we hadn't fully performance optimized everything, but it was stable and it worked. So that was definitely a consideration. And And I think as far as I think, one of the things we saw when people were doing, and sort of maybe this is where you're getting where you're going, is that semantic search only gets you so far. As your data grows, as the information that you want to retrieve becomes more sophisticated, right? Your semantic search is going to give you the top K semantically similar results. And what we were seeing is people were constantly, they're amazed by it at first but then they sort of like, well, this isn't exactly what we want. This has got other mixed up data that it's not really that relevant. And that, so then we started overlaying, and this is kind of what Nicola was talking about, is like you add new retrieval and new capabilities to RAG. And one of the things that we did was metadata retrieval, metadata extraction and retrieval. So you pair with the semantic search metadata that you extract from the documents. So now you can do a more focused filter on the information you want. This is very useful if your documents or your data is business records like invoices and receipts, things like that. That was I think an important, addressing. There's the scale, like just how much data we can handle, and then there's the scale of like how do you handle when you have so much data, finding the sort of the most precise information that as Nicola was talking about, we got to get the best data fit in that little context window.
Yeah, and also I would add that like there's not just vector. So RAG evolved a lot in a couple of years. So we started as an industry, we started adding hybrid search, so keyword, dense and sparse vector together, and then graph. A lot of graph RAG solutions are out there. Now they have incremental problems. They add up on the end because, for example, with hybrid search, you have to then re-rank and combine the results together. But for example, if you ask questions about a specific entity, specific person, for example, or concept or company, then you get things that mention that, and that's it. But you don't get anything around that entity that is connected to it. So that's where graph helps. But then with graph, you need to define an ontology. Most of the time, you build these knowledge graphs that are very hard to build. And the other problem is, how do you read them? Because you don't have a predefined read path, because the agent can do any kind of query, basically. That's the challenge. You have to query on any kind of perspective of queries. And then what you do, you have this ontology, and then maybe you relax the graph construction and you just pinpoint things together. But then there is another problem. One thing we saw a lot of our users were doing is, okay, but I need to filter by time. I need things happen last week. So last week is a very common word for a human. For a machine is a very complex thing because you have to parse the query. Also, it's not just last week, of course. You have multi-language problems. You have on the second week of May, all of these kind of things. And so you have to parse the query, and then you have to filter only chunks content that are related to that temporal range. But then there's another problem, for example, because maybe you filter by that range, but then you need information happen before and right after to connect the dots and have, reach full context. All these kind of problems are not solved by single RAG solutions. And I guess this is how we started building Hindsight.
Yeah. I'd also add, just on the ontology point that Nicola made, is that with knowledge graphs, you have to build an ontology, and they're hard to do, and you can use LLMs to do that. But what happens in the real world is the ontology changes over time, right? Or it should change over time because the understanding of the domain changes. So you do this static, I have this knowledge graph and all of that, and it's beautiful, it's pristine. And then 3 months later, your users are doing something different, or you've added new capabilities into your work process or something. And now the ontology is out of date. It's not that flexible, right? And as the models become smarter and the agents become more capable, they can ask more, they do more sophisticated queries. And you have to have a retrieval system and a RAG retrieval system that can keep up with that.
Okay, makes total sense. And there's a lot there, I would say. And I did follow, I would say, most of it. I think it all sort of makes sense. It'll all come together. probably in the later part of the interview, where I'll ask you sort of what an example would be of a client coming to you and what kind of data they'd have and the kind of questions that you ask them. I think that would be easier when you have a practical scenario in place. But something that I also wanted to touch on, actually the main point that I wanted to touch on with you guys and make the most of your presence today, was to understand why do you think that memory is A, becoming such a critical layer in AI systems right now, and B, where do you think we're at and where do you see us going, right? Because I just see I don't think dependency is the right term. I think right now we're more than addicted to AI, and it will be like an ever increasing exponential. Like it's something we won't be able to live without, right, going forward. So to me, having memory, right, that is what can I say, contextually aware, right, or having a layer in place that is beyond just the simple conversation that I have with an agent, but that is also able to what can I say, understand other conversations that I have with other LLMs or with other agents within the same LLM, is paramount, right? It removes that repetition of me having to say, hey, okay, so these are the documents, or you know what I mean? It's just very redundant in my mind. So you guys are the experts. Tell me why you think is so important, and yeah, what's next?
Yeah, so I would say that so models are moving so fast, and they're now capable of doing long horizon tasks. That's the main changes that happened in the last few months, maybe years, and then it's when something like AI is moving so fast, it creates this big leap that you have to fill with something, which is the AI stack, the famous AI stack that is not yet a standard, I would say, probably because the AI part, the model part, is moving so fast that it's hard to even predict where it will stop. Because if you look at the products being built like last year, probably 80% of them have been eaten by the models itself. Because they can now, like all the LLM wrappers, you know, the famous, say, OpenAI released the product and then they killed hundreds of startups. That's true, and it's still happening today. So we believe that the memory is the best friend of the model. It's not going against the model, and it's something that fundamentally can't be written in the architecture of the model itself. It's a different business. They are complementary, but hardly going to be replaced by models. Maybe this sentence will get old very badly. But if you think like a software industry, for example, which is the most impacted at the moment, in my opinion, is with coding agents, anyone, even without technical knowledge, can build basically any kind of small application that works. And these are long horizon tasks, because you tell the LLM what to do and they figure it out. But the next time it has to do a similar task, it starts over. And so every time you yell and you say, you curse at the model, you want him to remember that you cursed. It's like talking with a colleague, right? You don't want to start over with a new colleague every week or every day. And so the memory plays a fundamental role here. But it has to be built on the environment, because one thing I really believe is people are used to have habits, even in tools, even in using computers. And so when you start using a AI tool or a tool in general, and you like it very much, moving to another tool that does the same exact thing, maybe it's even slightly better, becomes very hard, because you're used to that and you don't want to lose time and spending your productivity time in that switch. There's also an emotional sphere on that, I guess. But then the memory, it's the kind of sphere that can bring both the tools together, so you can do the switch easily, for example, or you can do both for different purposes. For example, you can put together different LLMs and remember your chats between maybe Claude, OpenAI, Cursor, whatever you use. And they can remember about the context you're working on, even if they are different tools.
Yeah, I would add, there's definitely cross session and making sure that you're your agent remembers, or and we all see it, like as software engineers, we all see this. We all use Claude Code or Codex or something like that. And as Nicola said, we get frustrated having to tell it over and over again the same things. So early on in sort of hindsight, which I'm sure we'll get to, I was doing some experiments, and I was sort of tracing what was happening in the coding agent. And what the insight I had there, and this isn't even cross session, this is within one session. I don't know if everyone's familiar with how it works. Like the conversation that you're having in your coding agent, that's getting sent to the model every time. And it gets larger and larger and larger. And it's in complete history of the conversation you have. Until then, I'm sure everyone's had this moment where they've seen, time to compact your conversation. And this is when the agent becomes dumb, right? It forgets everything. But what I realize is one thing is that the way it's being solved today, even by the foundational model providers, because these are tools provided by them, is that they're taking the entire context and they're giving it to the model, and they're asking the model to do two things at once, right? They're asking the model to figure out the task at hand, like write this code or debug this problem, right? That's number one. And number two, they're saying also figure out what's relevant in this mass amount of data of the previous history of this conversation, and use that information to apply it to the task. As good software engineers, this is something that feels wrong. It feels like we should have a separation of concerns here. There should be the model should focus on doing the task correctly and efficiently, and there should be a separate system that is concerned with getting the most relevant contextual information into the model to use at that moment. And I think that's where there's a clear separation between the model and memory, and that part, of course, is memory. Memory's job is to remember everything, to store everything that's happened, and to surface to the model at the moment when it's doing a particular task the most relevant information based on the user, who they're interacting with, what they've done in the past, maybe what other people in their project are doing. It has to have access to all of that, and it pops up. The perfect system pops up the most relevant piece of information that it can use to be successful at that moment. And that's non-trivial. That's not just like throw everything in a database and retrieve randomly. It needs to be smart, because the models that are today going through the entire conversation history are smart, very smart. In fact, one thing we noticed when we were doing a lot of benchmarking in early days on Hindsight is the thinking models. I think that the thinking models, one of their core values is that they can handle all of that context. It's one thing to have a 1 million token context window. It's another thing to actually be able to make use of it, right? And you can get a better result in a benchmark that does memory kind of benchmarking just by giving it a thinking model. So it does a better job of thinking about the context that you pass to it. And you can pass to it a lot of context, and it'll still be able to understand it.
Yeah, every answer here is I'm gonna say food for thought here, but it's I understand it. So you're almost looking at it like a parallel, like, what can I say? Like if you're looking at them like at the railways of trains, right? They're almost two railways that are always going to be side by side for one another, right? More or less, so you could say that. And they should always be closely aligned. And depending on the nature of the query or the architecture or stack in question, the pattern, let's just say, or the design of such railways would differ in a way, right? Like very sort of, what can I say, streamlined, let's say, in layman terms, more or less, or no? Would you say?
Yeah, I think that the model should be on its own track, and the memory system should be on a different track, and we should be optimizing them independently.
Exactly.
On the memory track, that's where we ride. And we
exactly.
in Nicole, fantastic work with Hindsight to make this work better, right? And
right.
I think there's work to be. By the way, I think there's work to be done on the model side. I wish the model providers would fully embrace this separation of concerns, because I think the models could be smarter about using injected context, and being, because sometimes they don't use it, right? And that's like a training thing, not a
okay.
Yeah.
So, Nicola, before you jump in on this, right? Because I wanted to ask you, it seems to me that there has to be sort of like a demarcation and a separation between the two, also for security reasons, right? Given what happened yesterday, right, with Claude, and I saw your comment as well, and I think it was almost like a perfect assist for the world to know what we're going to talk about today. Would you be able to use that as an example to very briefly describe what happened, right? And we're talking about Claude here, Anthropic, also known as probably like the new Google, right? And everyone uses Claude. It's probably the most renowned model out there in the world right now. So explain what happened, and what are some of the concerns, right, that people should be, maybe not everyday users should be aware of, but sort of it's probably an event and an instance that happens that is probably distant for the average person who uses Claude for, formatting their email, but it's probably something that they should be aware of, right? And that such episodes can also happen at that level.
Are you talking about the Claude Code source being published?
Yeah.
Because I read today that it was a human, actually. So they said it's a process problem. It was a process problem, and they are automating it. So actually, it goes on the counterpart, because it's like we had this human in the loop, and we want to remove it and add more checks through AI. But I would say maybe we can talk about very briefly, like about the recent vulnerability attacks that have been done on very popular libraries, both on NPM with Axios, which is a HTTP library, and Light LLM, which is used by millions of developers every day. That's a problem that we are aware, because we are in the open source space. We receive so give more context. Like basically, there was a external contributor. Both the projects are open source, so anyone can open a pull request and with some code to add to the project. And the maintainers, usually before AI, they will review manually, and before you make a contribution, you have to understand the code base. You have to understand, and if you want to do a attack on the code, well, you have to have the knowledge. First of all, you have to know how to mask the attack. There's a lot of knowledge for the hackers to have. Right now it's very easy, because you ask Claude, and you can kind of bypass the ethical and security guardrails they have, and say this is just for playing for fun, and then you put it on a real repository. And so basically they accepted this contribution that had a script. I don't know exactly the technical details, but basically it was reading all your environment secrets about Git, AWS, whatever, and passing to a malicious server. And so basically they collected a lot of a lot of credentials. Now this is not a new problem. The new thing here is that you have so much slop coming on open source project, especially popular ones, because people can do actual legit things, and they want to improve your products, but you have no idea if that's their real goal or not. And I don't know exactly the detail, but I guess they just merged it because it looked okay from first glance, and that's it. And basically they got they basically ruined their own reputation also, because I will never trust those providers anymore. And with AI is a real problem, and a lot of companies are working on that, I would say, on the good.
Yeah, I mean, I think like the velocity with which you can write code means the great thing about it in open source. The great thing is that anyone who reports an issue can probably also fix the issue, which is great for open source. But it also, but it used to be like, we've worked like Nicola longer than me, and we've been working in open source, and someone would report an issue and they're like, please fix it for me. And now it's a lot easier to say, it's probably because you spent time debugging it anyway, to have your coding agent just put up a fix for it and see if the maintainers take it, which is great for the project. But then the volume of this stuff to be reviewed becomes so high as your project becomes more popular. you start using potentially, AI methods to review all of the code, because there's a lot of it, and then there can be loopholes there, right, where things like these malicious attacks can get in. Like, imagine a project like OpenClaw, which has a ridiculous number of GitHub stars in popularity. Like, I can't imagine how many pull requests they get in a day. There's no way a human could review all of that. So these are the kinds of challenges we're going to have going forward, and we all have to, be diligent and figure out, putting a human in the loop sounds like the simple solution, but it's not scalable.
Yeah, I think getting back to the RAG system and production system on memory, auditability, and having a way to roll back versions and look at what happened on a particular agent session, that's I would say observability is fundamental. First, because the model can do anything and you don't have control over that. Because I always say that the good thing about models is that they can do anything, and the bad thing is that they can do anything, right? And so yes, the memory helps you separating the concerns of what the model knows, it can have seen and done, gives you much better visibility.
Yeah, and we're having conversations now. That's a good point that Nicola made, with customers in restricted industries, right, where there's lots of sensitive data. They want the compliance, right? They want to be able to. So as a memory system, our memory system is one we say it learns, right, and it does that by synthesizing data and creating new data, new facts, new observations, new mental models. And they're asking, so how do we make sure that doesn't get poisoned, right? So this is where we're adding audit, human in the loop. Like, we're going to update the data, but we need a human to approve it. And then, once the system, your trust in the system is high, then you can have it maybe go automatically. But you still, for like standard compliance reasons, you want to have an audit trail of that when it's changed. And so if something does go off the rails, how do we know and what happened, and how do we course correct it, right? It's increasingly, I think,
which is sort of similar.
Yeah, go ahead.
Yeah, it's sort of similar to what Nicola mentioned, right, regarding the incident, right, with Claude yesterday, right, with Anthropic. They were able to understand, essentially do like a post-mortem, let's just say, of the accident, understand where the leak was. Sounds like a Pentagon operation, but and probably rectify it accordingly, right? I'm sure some heads did roll, because it's a big deal. It's a big deal, and it was the talk of the town yesterday. But I guess it gave them some publicity, right? And not that they needed it. But now going back to Hindsight, right? You mentioned it here and there in some of your previous answers. I would say, given the time right now, we've set the scene as to what you guys do, right? Would you be able to present what Hindsight is, probably by using a real scenario, right? Of you don't necessarily have to name a client, or say you can even use a hypothetical one where you have an entity or a business of any kind that comes to you and explain essentially what you do and how with Hindsight from a Vectorize standpoint.
I can tackle it. I can give you anonymous kind of scenario. We had
of course.
Yeah, we had a customer in the edtech space, and they came to us, and it's interesting because their challenge was exactly the scale issue, not in the we have so much data. They were hitting the top K semantic search problem is not giving us enough results, and they recognized that as they added more data to they had I'll say just a standard kind of RAG system. Okay, and they're doing vector search and doing semantic search top K, and they realized they wanted to add more and more data and add more richness to their system, but they realized as they did that, it didn't scale. Like, the top K wasn't getting them the results that they wanted, and so they heard about Hindsight, and they started talking to us, and we've been working with them to try to solve that problem. I think fundamentally, Hindsight is designed to solve this problem. Where you have a lot of, one of the things that it does is that as information increases, we have to be able to find the right information. And so what we're doing now is, as they do analysis on particular data, and they wanted to layer in more levels of analysis, and they wanted to sort of all accumulate on the one all together, so that instead of just randomly pulling stuff that may not be relevant to that analysis, they want to keep adding more and more. They're doing automated analysis of their sessions, and so they run one analysis and they run two analysis and they combine them, and now that worked all right. But now we want to add a third level of analysis, and now it starts to break down because it's pulling back the top case, pulling back facts, unrelated facts, and we do have a context window limit. They're larger today, but we can't put 2 million tokens into the context and have it being used. By the way, there's context rot. Even though you have 1 million tokens, most of the studies show you can only use about 150,000 of those effectively. So even if you have a huge window, so you're hitting on that limit. So you still have to be able to. It's still the same problem that we had before, only it seems less urgent if you hit it later at higher scale. So they've adopted Hindsight as their RAG system, and they put all of their data in that, and we've helped them to sort of be able to get the richness and be able to add the additional analysis that they want, so they can get better understanding for their agents, their AI agents, and their chatbot as well for their end users. So that's
So
go ahead.
I raised my hand like at school, right? So in this instance, right, in the integration phase, what does that look like? Because I understand that you must have, like a very intelligent system. How is it able to innately, take in and integrate seamlessly with any kind of, because I mean, data is like water, right? Like it differs depending on the context, the industry, the sector, right? So what does that integration look like, right? Is there like a standard data feed process? Do you meet a bunch of times? So
Yeah, I mean, I'll let Nicole maybe talk about the missions, how we use missions in Hindsight.
Yeah, so basically, when you want to start to adopt any storage/memory system, what you want to do really as a first step is to establish some evals. So you have so basically, as like building a new feature for a product, you have the spec and you have the requirements, so you know the outcome you want. Otherwise, you start doing things that don't matter at all. Okay. So the first step is always to set up some evals. Could be just a couple of questions with some expected answer. And also, usually what you do is, okay, run this eval. This is the question I put into the system, in the entire system as a black box. And then I get the response out. And I can visually, by the evals, I can evaluate if the response that I get from the system is similar or acceptable based on my standard. The next step on that is put an LLM, because they can automate things.
Sorry about that.
Okay. So you can put an LLM to do that as well. But that's the very basic.
That's the client calling.
And so you do this eval, and then okay, you start to see the system does a very good job or very bad job, it depends. So you have to tweak the system. We have a lot of configuration options that you can set in a memory bank, which is like a storage of your memories for a specific topic or domain. For example, I think the most important one is the retain mission, because the retain operation in Hindsight is the write operation, basically. So I give you all these documents through retain API, and there is a mission. So the mission is a text area, a bunch of text where you instruct the LLM to behave in different ways. So maybe you want to retain every single detail on the emotion, from an emotions perspective, emotive perspective. For example, if you're analyzing a conversation, you want to analyze both the users, how they are interacting with each other, if they are sad, if they are excited, all of those. But maybe you're analyzing the same exact source data, but you don't care about that sphere. You only want to know how the conversation ended and what was the decision made. Maybe it's talking about product or so those are very two different goals you have. And so through the retain mission, you can instruct Hindsight to to focus on those goals, and that help and then help the extraction and the memories that gets created and retrieved by the system. But most of the time, what you really want to do in the eval is to separate, have a way to troubleshoot the system and separate and see the prompt that you pass to the LLM. Now, the most basic case is I do a retrieval, and then I pass all that context to the LLM and say, answer this question. That's the most basic one. And that's easy to troubleshoot because you can see the prompt that you got, and what the LLM did. And so you can see if the problem is in the LLM, the problem is in the context, why are not we getting the right information? If the problem is the memory system, you can go in Hindsight and change tweaks the configuration and see how it changes. But the problem becomes even harder if you put, for example, an agentic loop. An agentic loop usually is what they call a long horizon task agent today, which is basically I loop until I get to resolve the problem. And I do that through tools. And that tool usually is a call that you can make to the memory system with a query and say, okay, give me things about this. But then you do another query. Okay, now I found out that this user was happy about X. Why? What is X exactly? What happened to X in the last month? So you do another query, and the agentic loop puts the context all together, and at some point it decides, okay, I have enough context to answer, and gives you the answer. In that regard, like troubleshooting, of course, you have multiple queries going on, so you have to see where the context was wrong, if the context was wrong, or just an LLM reasoning problem, because we are seeing that, as Chris pointed out, like there is even if the most modern models support millions of tokens, like there is a threshold around 100K, dependence on the model, on the provider, where after that, they just basically ignore what they see. Some models are better than others, so you might want to change the models as well. They have different pricing. Some are more trained to use tools, so they use tools better, which is another important point. For example, one thing we did in Hindsight to help users to find out what's the best model to use for that specific operation, we ran these vals on a data set. We have that's Locomo, that's a pretty known benchmark in the memory space. It's very limited benchmark, but the good point is that we can put some constant. The constant is Hindsight and then configuration, the data set and the answer. And then we can change all the models, we can change some different configurations and see how the score changes. And we published that because people were asking, like, okay, I want to use Hindsight. I know that. What model should I use? Because Hindsight doesn't have a model itself. That's the pair you have to make. And so in order to answer that correctly, we did our homework and we published the result.
Yeah, I would just add, so I should add, so just getting back to the original example I talked about. So we built a vals for this customer, and then we iterated on those, and then we've tuned their missions for the retain missions and various things, so that actually when Hindsight analyzes the incoming data, it has like expert level domain knowledge of the domain. So the observations that it's making and something we call mental models that it's creating are all domain specific for that domain, so that the data when they retrieve it is much more aligned to what their agents need and what their end users are expecting, because they're building into this space of experts, of domain experts. And we think this is a
super clear.
Big differentiator on
It's a what? Sorry?
We think it's a big differentiator. You know, we say that Hindsight is the memory system that learns, and this is how it learns.
So it's adaptive and dynamic in its nature, essentially, right?
Yes, and you can steer it in the direction for the kinds of because typically when you build an agent or have a chatbot, even, it has a purpose, right? It's not like it's not answer questions about Wikipedia, right? So you can steer it in a particular direction, and then it's even more efficient at doing what you want it to do. And
in that hypothetical scenario of yours, right, and that you've just described and presented, how would you be able to assign timeframes to the different phases that you've described? Like, how long are we talking? Like a week, 2 weeks, like from your end?
Yeah, I mean, a week or two for each one of these phases, right? And so that we kind of get to, week or two on evals, make sure we understand that, week or two on sort of tuning the missions, getting them domain specific, and then like another week or two of testing it to make sure it's, so this is something you can, in a month or month and a half, you can kind of get completed, and you can have a very focused system, very focused memory system that's, tuned to what you want it to do. And by the way, this is all like, our main sort of container is a memory bank. So you can do all of this on a per bank basis. So you can have multiple agents with different sort of goals, right? All in the same Hindsight system. You don't have to spin up like multiple Hindsights to do this differently, right?
Okay, I understand. And seeing, because of course it's the reason why our paths crossed, right? Is the traction and the recognition, I would say, is probably a better term, that you received from the open source community, which I find amazing, because it's all based on pure merit, right? And there's no pollution involved, right? Of gimmicks or bots and stuff like that, which I think is going to grow ever more relevant now with AI and everything, which is so hard to discern between what's real and what isn't. First things first, well done. And second, what kind of teams or use cases are you seeing adopting Hindsight currently, right? Like both with teams that are, of course, reaching out with you guys directly, and as you mentioned, working on a client basis, right? As well as people forking, and what are they using Hindsight for in general?
Well, I'll let Nicole answer that, because he talks to the users the most in our Slack channel.
Yeah, so I think there are basically two different separated use cases that people are building with Hindsight. And one is, I want to improve my personal productivity. So basically I'm using, I don't know, Notion, Obsidian, whatever, some place that I put my knowledge on, and maybe I read also other news from blog posts and stuff. And I want a central place, central mind to remember everything. And Hindsight fits into that very well, because first, there's no concept of conversation. Most memory systems have this endpoint like add conversation, but maybe you don't want to only retain conversations. You want to retain, blog posts, for example. And so you can do that. You can self-host it locally. And we did a very hard, like we put a lot of effort on making Hindsight to run locally easily, because, for example, Hindsight is built on Postgres. Now, everyone knows Postgres, I guess, but there's no easy way to spin up a Postgres locally without using Docker. And so we did another open source project called PG0, which is basically a wrapper to run Postgres locally with very low footprint, and you don't have to install anything else. So can run on any machine. And this streamlined the quick start for Hindsight a lot. And so people for personal productivity. And then all of a sudden I see personally people reaching out to me and say, okay, I work at this Fortune 500 company, and we are adopting it in our teams. And we want to have a single place to collect our own work. Maybe they are working, in software, so they want to share the Cloud Code sessions between across the team, so they know the decisions are tracked and everything. Or maybe there is a third use case, which is actually building user-facing AI applications. If you can think that as maybe an evolution of the chatbots, but way more built into integrating into other systems, like the example that Chris made. Like that's a user-facing application, and I'm seeing that on open source as well, because people are asking. Like, how do I self-host it? And they have very different requirements, which I think tell us that there's no single like niche that is adopting Hindsight, because they are running on Kubernetes, they're running on different cloud providers. They want to self-host on a bare metal machine with no resources, for example. That's interesting challenge. So I would say it's a very diverse ecosystem adopting Hindsight.
Super interesting and very intuitive, I would say, easy to understand. So for the first instance you mentioned, which I think is probably the most relatable, right, for the average person here, which is, everyone who works, probably, let's use digital nomads as example, right? Folks who work from home, and I'm sure everyone has different routines based on what their role and responsibilities are. You mentioned, which is interesting, right? How is Hindsight sort of agnostic in the way that it's sort of it receives information, right? So can it be a blog post URL? Can it be what can I say? Like a PDF? Can it be like a copy and paste of like a data dump, or like, you know what I mean? Like, is it compatible with anything?
It's not compatible with anything, but it's compatible with text. And in this area, building conversion layers or like hooks or exporter is like 10 minutes, it's done. Now, you don't need an ATL layer to convert unstructured or binary documents to text, because there are a lot of alternatives today, free, open source. We support natively text and PDF, Markdown, but really, like, people are even if they're not technical person, like, they can easily find a way to translate those information into text or a compatible format for Hindsight. One thing I want to mention, for example, is since there are a lot of products for personal productivity, and we are seeing a lot of people saying, okay, I built. We also have a connector for OpenClaw, for example, and we are seeing a lot of people like using that for OpenClaw, because OpenClaw can manage all your everything, all your personal devices, anything. And so that's a very interesting place to be, because you need to connect the dots between all your devices and conversations, for example. But we are also seeing from the community, I built this for Obsidian. Can I submit it to the Hindsight repository? So initially we said yes, of course. Let's put it in the repository. But due to the volume and the fact that we have to maintain all those plugins, we started a community integrations hub, and so people can submit their own integration, so others can download it and test it.
Nice.
Yeah.
Yeah, I think, like, I would add to, like, the OpenClaw and now Hermes Agent, which is having its a GitHub stars moment. I'm sure if you're following that, Eric, you've seen that.
It's crazy.
Yeah.
Crazy.
So we see people using our OpenClaw plugin quite a bit. Actually, the other day, Nicola, tell the story about the release you did the other day on the OpenClaw.
Oh yeah, so I did. So we recently decoupled the main project release to the plugin. So I started doing all the releases for every plugin to detach the history. Basically, a user contributed a contribution in the OpenClaw plugin, and all the CI was passing. So we merged it and was okay. But there was a very stupid bug. It was in a JSON there was a comma where it shouldn't be. And so basically the install OpenClaw wasn't working anymore. All the tests were passing because they weren't looking at the packages, basically, but it was working. Like 10 minutes, we had the 2 open issues saying, doesn't work anymore. Like, really, guys, I just released it. Like, give me time to to do the announcement. I didn't even do the announcement, and there were 2 issues open. And in fact,
Crazy.
we are seeing a lot of like, honestly, like in the last few weeks, I wake up in the morning, saying in the Europe, like, right, and I wake up in the morning and, like, from the evening when I check the repo status, because sorry, I'm addicted to it, but I look at the issues and, like, maybe there are 20 and I solved like 10 in the same day, and then I wake up and there are like 25, and I'm like, oh, I can't keep up. And most of them are legit, and likely most of them I also have a pull request that solves the problem, so it's not
Yeah.
But
Yeah, I'd say like the community engagement on the project is like kind of blows my mind. I mean, we both worked on Apache Pulsar, which is an Apache Software Foundation project, and very popular, well used. But it's more of a, you have to have a big problem, you have to be a bigger company to use that kind of software. Whereas Hindsight has appeal, like Nicole was saying, to individual developers, individual users. So we have a bigger community.
Retail.
But they're very open to helping, right? And so it's kind of like, we used to sort of have to beg for people to help out with Pulsar sometimes, but that's not the problem here. People are like, it's amazing, want to help, want to make it better, want to contribute. It's been fun for me. I don't know about Nicolo.
Yeah.
I mean, guys, I think the word that you just used is what comes across from you talking about what you're doing, right? Which is fun, right? Because ultimately that's what it boils down to. I think also when you do things naked, let's just say, so you do them in the open, when you're building in public and you're releasing everything, it's I guess you have to be curious and passionate and have fun doing it, right? Otherwise, I would say probably people catch up, right? And probably will stop helping you, because also it's so easy to move on to the next big shiny thing within the space. So it's been a lot of fun, I would say, to learn A, from you, more about you, and B, about your solution. We'll definitely do this again. I'll chat with both of you separately, because I might want to implement this separately as well for my own data routine. And next time we'll speak, I'll provide some direct raw user feedback. And is there like a last point that you'd like to leave the listeners with? We have literally a couple minutes, and then we'll wrap it up.
I would just say, I think memory, and I mentioned this before, like I think agent memory AI is going to be a key part of the stack. And I, this is, I don't have it to share, but we saw this at the last NVIDIA conference, right? They show the AI ecosystem, and these guys, obviously NVIDIA's plugged into what's going on, and memory is right there in the diagram, right? And it's like, so it's going to be, I think it's a real thing. And like I said, the separation of concern, I think it makes sense to me that memory evolves on its own, improves on its own. And I guess one thing I'll say is that I don't know if we finished, I know, the benchmarks on this. Maybe Nicolo, you want to talk about the Beam benchmark quickly?
Yeah, so like very quickly. So we launched I guess last week, 2 weeks ago, we launched because the memory space is very there are many players right now, because memory is a thing. So and people are doing a lot of memory systems, and also because of the coding agents. You can try a POC in probably 1 hour, and so there has to be a way to evaluate and compare different memory systems. And usually the thing is, you run the benchmark. There are industry benchmarks, and so when we launched Hindsight, we crashed all the benchmarks that were out there. And in March, I think in February, a new one came out, and the existing one that are Locom and Longman Eval are very saturated, and most of the memory system you can get 90%, to give you a number. And this Beam benchmark is way more large, like a conversation of 50 meg of text. If someone has ever seen a 50 meg file of text, he knows how dense is that. And the challenge is always the same. Like, okay, there's the conversation. You can imagine probably years of conversation between people and or a company. Find the right way, find the right information to get the right answer to the question. And we crashed on that. And we just launched the Agent Memory Benchmark, which is an open way to evaluate memory systems. And we had the Hindsight, but we didn't do the Beam one because we haven't had the time to do the results yet. And we just released today the Beam results, and we are state of the art on all the splits, so on different sizes of the conversation.
Congrats, man!
Thanks.
Yeah, it's a big thing for us.
Achievement.
Yeah. Yeah, and we're committed to like moving the space forward. So that's why we open source the benchmark code and how to do it, and helping people evaluate what's out there. But we're constantly looking for new benchmarks to challenge ourselves. Like Nicole said, the Locomo and Long Memeval are saturated. Like if everyone's scoring in the 90s, they don't mean that much anymore. What was the baseline score on this on Beam? 40% or something?
Yeah, on the hardest split, yes, it was 14.
And we came in. Yeah, where did we come in at?
64.
64%. So
now it's a new those numbers, guys.
Yeah.
There's I would say there's no better note to end it on. So I guess the proof is in the pudding, right? What you've been doing is working. So I would say keep doing what you're doing and keep having fun. And yeah, I mean, it's been a blast. So thank you very much, Chris. Thank you very much, Nicola. And we'll definitely chat again. And yeah, until next time.
Thanks, Eric. It's been great.
Thanks, Eric.